Okay, so chapter 4, day 5 video. What we're going to look at today is what is a composition of functions. All right, what is a composition of functions? Well, a composition of functions is a function followed by a function. I believe you did this in geometry when you did a composition of transformations, when you did one transformation followed by another. Now we're going to use functions. We're going to evaluate one function and then follow it up by evaluating with another function. Let's take a look at what we mean by this. Okay? So, here's an example. That is just a bullet. You don't even need that there. All right? So the g of x inside with a big set of parentheses outside with an f. We read this as the f of the g of x. Instead of saying like f of 5, it's the f of the g of x. So just like you did with geometry, you have to do something first. We do what's inside the parentheses first. So we do the g of x first, and then use that answer for the f of x. So we're going to do this function, evaluate it, get an answer, and then apply it into the f function. Watch. Let's also notate it just real quick. See how this has a big set of parentheses and then the g of x is inside it? I could use this open circle, which I believe you used in geometry. So the f of the g of x, again, do this first and then apply this into the f. So let's take a look at an example. So here's two functions. I have f of x is 2x plus 3. G of x is x squared. I want to do the f of the g of 5. So again, I have to do the g of 5 first. I have to do that first. So the g of 5, well, that means take the g function, if you remember what this notation meant, put the 5 where x is. I'm just evaluating the g of 5. I'm taking this value and putting it in for x in the g function because it says the g of 5. So 5 squared is 25. Now I have to do the f of whatever that answer is. So now I need the f of 25. That answer goes in there. Well, the f function says take 2 times it plus 3. So the f of 25 would be 2 times, I got to put x there, plus 3. 2 times 25 is 50, plus 3 is 53. So the f of the g of 5 has an answer of 53. We're just evaluating. We're not solving for x. We're evaluating how much its value is or how much it's worth. And if I put a 5 in to the f of the g of 5, I get 53. Take a look at another example. Keeping in mind, we're still going to use the following. F of x is 2x plus 3, g of x is x squared. So we're still using these. I want to find the f. Oh, I don't want to find the f. I want to find the g of the f of 3. So which one am I going to do first? I always work inside, so we're going to do this first. The f of 3, so I ignore this for a minute. And I go, okay, I can do the f of 3. So wherever I see x, I'm going to put 3. So the f of 3 is 3 times 2 is 6, plus 3 is 9. So this whole thing here has a value of 9. So now I want to do the g of 9. So I do the g of 9. This 9 goes in here, because that's how much this was worth. And the g of 9 is, well, 9 squared. the g of 9 is 81. So the g of the f of 3 has a value of 81. We're just evaluating how much it's worth. Let's take a look at this one. Okay, so again, using this notation, we do this first. We do all of this first. So we ignore the p for a minute, we do the m of 2. In the m of 2, well, here's my m function. If I put a 2 in, 3 times 2 is 6. I take that answer and put it into the p function. So the p of 6, again, that 6 goes right there. Now I go to my p function. It says to take the number and square it and add 1. So 6, I put it in parentheses, squared, add 1. 6 times 6 is 36, plus 1 would be 37. And that's how you find, using numbers, the composition of functions. Now, we're going to take one last little look. Here's my original ones that I started the day with. Now it says find the f of the g of x. So I'm not using any numbers. And so if they don't give you numbers to put in, you have to plug the entire function in for x in the f function. So watch what I do here. I want to find the f of this thing. Well, what is this thing? This thing is x squared. So I'm going to take this whole thing, whatever this whole thing is, and put it in for x in the f function. So this will go right there. So I write this out as 2 parenthesis, what goes here? All of this, whatever it is, plus 2. Well, I have 2 times x squared, that's 2x squared plus 2. And that is the f of the g of x. When you do not have a number, you plug the entire thing of whatever this is into that. This whole thing goes into the f function if they don't give you numbers. Let's look at one more. Again, using my same functions. Find the g circle of the f of x. So all of this, since they didn't give me numbers, is going to go into the g. The entire f into the g function. Here's my g function. So that is whatever the f function is squared. So 2x plus 2 squared. Because the entire f function has to go in where x is into the g function. So, square. Well, we know when we square, we can't just do first and last. We have to write it out twice in FOIL. All right? So, now let's do our normal FOIL process. 2x times 2x is 4x squared. 2x times a positive 2 is a positive 4x. Positive 2 times 2x is a positive 4x. And a positive 2 times a positive 2 is a positive 4. Clean it up, I get 4x squared plus 8x plus 4. And that is what I get, simplified, when I take the f function and I put it in for x in the g function. So, this is composition of functions with numbers, starting here, plugging in, taking the answer, plugging in, and with letters, where if you don't have any numbers, you have to plug the entire function wherever x is in the other function. We'll work on practice problems on that. Class.